Welcome to Purple Fire's event report for FaireFights 2021. Let's get into it.
What's up, guys? This is Reed Canyon Kaufman with Team Purple Fire Robotics at Florida Polytechnic University. I am the lead of the combat section here, and this is our event recap video for FaireFights. I am the driver of one of our 15-pound robots, Hyperion. Hyperion is our two-wheel drive small vertical spinner. Going into this competition, we definitely were the ones to beat. We won first place last year with Hyperion and second place with Themis, our other 15-pounder. So we really had a big target on our back. A lot of people were gunning for us specifically, which is good. It definitely lights a fire. You really got to fight to make sure that you can prove that you are the best. And we just didn't have enough time with a lot of the things that were going on. We'll get into that. Other teams had a lot of time to work on their robots, and because of the pandemic, we didn't have as much time as some other people. We went into the competition. Our first match was up against Side and Spinner, and Kurt is definitely an individual that I enjoy interacting with and even more enjoy competing against. He has no limits, definitely a showman, and that fight was a lot of fun. It was short. He got a knockout against Hyperion. Our batteries, we picked the wrong batteries, put the wrong batteries into the robot, and they just couldn't output the number of amps that we needed to get our weapon spinning. And Kurt was on a roll. Side and Spinner was up to speed immediately. Almost box rushed Hyperion before we were up to speed, and we were flying across the arena. It was fun, but it didn't last very long. He got us up on our face, 2 hits I think, and it was a knockout. From then on, that kind of set the pace for the rest of the tournament, where Hyperion was in the loser's bracket and we were struggling to get back up to the finals. So our next fights, we just had problem after problem after problem. Using the all UHMW frame that Hyperion runs, we ran into quite a few issues with gyroscopic precession. The 2100 kV motors on 24 volts, they don't play well with a flexible frame. So when Hyperion would turn as fast as it could, the weapon would stay in place and the frame would essentially rotate around the weapon, which fed the output shaft of the weapon motor into the rotating plane of the weapon. So when those two come in contact, the weapon is always going to win, and if it didn't shear the outer face off of the pulley, it would just shear the entire output shaft of the motor off and fire it out the front of the robot. It was enjoyable to see, just a chunk of aluminum going flying out the front of the robot at about 250 miles an hour. But my wallet, the wallet does not like that. So we burnt through about 2 motors on average for every fight. A drive motor would go and the weapon motor would break. So we have a lot of things that we need to work on for next competition. And weapon design certainly is not one of them. Frames are difficult, especially when we're working with this high of a kinetic energy value. We already have some ideas. Moving forward, I think we're going to scrap Hyperion and turn that into a training bot. And we're moving forward with a couple new 15s with some things up our sleeves, some tricks up our sleeves. So definitely watch out for those. We got over the batteries, switched from 4S lithium ion to 5S LiPo. Had no issue with amps or volts anymore. All of our power consumption problems were gone, but that brought about quite a few other issues. Our new weapons for this year were designed fantastically to impart as much of their kinetic energy as possible into whatever they hit. So when they impacted, all 4.7 kilojoules of energy would go right into whatever that contact surface was. And because we were using a subpar weapon motor mount, a lot of times what our weapon ended up hitting was the motor shaft. So we would maybe get about 30 seconds to 60 seconds of a match with an active weapon and then shear off our weapon sprocket, clean off the motor shaft. Took the motor shaft with it most of the time. So we burnt through 3 weapon motors and switched over to our backup weapon motors, which had a beefier shaft but spun a lot slower. and sheared right through those as well. Ran a couple of matches against 2 Days. 2 Days was a robot that, by its name, kind of explains a little bit. They built it in 2 days. I think it was their first robot that they built and competed with, and that was a fun match. We didn't have a weapon for the first match against 2 Days, and 2 Days is just a big wedge bot with giant tires. So he's able to move that thing across the arena, and he could have bullied Hyperion around a lot. It was a match of driver skill, and that was the most fun match that I have had in years. That was a lot of fun fighting 2 Days. And then we got to do it again on Sunday morning when we had an active weapon. That match didn't last as long. We were able to rip off one of the drive sides on 2 Days. After that, we continued through the tournament, ended up fighting a robot named Bumblebee that was built by an ex-teammate of ours. He and his brother wanted to compete with each other, so they left Purple Fire and decided to start their own team. And my gosh, their robot is terrifying. It has a huge vertical spinner on it, big dually tires. It was a force to be reckoned with. Bumblebee ended up getting second place, losing off to Themis. Themis got first place at the tournament. We just couldn't outreach the weapon on Bumblebee. It spun incredibly fast and was, I believe, 8 or 9 inches in diameter. It was huge. So I'll pass it off to the next. Thank you, guys.
Hello, my name is Matt Leiden. I drive our 3-pound robot Solarstorm. Solarstorm is a 3-pound combat robot. We configured it as a horizontal undercutter. It has an effective diameter of about 7 3/4 inches. In terms of drive speed, we use brushless drive. Just some, I think, 2308 brushless motors mounted to some planetary gearboxes. We use a large 3536 motor mounted in an overhung configuration to drive our large weapon. The weapon on Solarstorm spins at about 260 miles an hour at the tip, and I think that's about 13,000 RPM or so. It ends up storing about, I want to say about 800 joules of energy. So Solarstorm can certainly pack a punch, and during testing we measured some of it. Unfortunately, the robot wasn't fully operational until the actual competition itself, so we didn't get to do as much as we'd like, but we're certainly going to end up doing a lot more testing before our next competition as we revise the design. There was a lot that went into designing our Beetle weight. We spent about a year in the design and prototyping phase, and as we went through each scenario, prototype, and revision, SendCutSend did a really good job of machining the parts. Despite being laser cut, the parts we received were just about perfect, almost always press fitting with our bearings, shafts, and other hardware. This is the first version of our weapon for Solarstorm. It's AR500 with a rake angle of 12 degrees and a relief of about 11. During spin-up tests, the bar performed excellently, usually maxing out at speed in about 1.5 seconds. We ended up refining the design further to what was seen at competition at FaireFights. For a closer look at that design, keep an eye out for our video on designing for laser cutting. Like so many robots, Solarstorm was born a little bit overweight. When the design was completed, it came in about 4 ounces heavy. As we redesigned the chassis, we decided to use a slightly lighter, more flexible 5052 aluminum alloy. While it gave some weight benefit, our primary use for this aluminum was to absorb energy. Because of its high flexibility and fatigue strength, it made it a better option for combat. This chassis could take big hits, just warp all over the place, and then we could go back to the pits and bend it right back to flat. In the end, we got the bot to within the weight limit, and it turned out pretty nicely. In the week leading up to the competition, we waited really anxiously for some last-minute parts to come in. Unfortunately, some of those essentials like wheels didn't make it in time. Though, our resourceful team got together and we got the robot working. We did end up losing our first match because of some motor clearance issues, which ended up being a recurring theme throughout the event. Despite my pleas for him to send the robot into next week, the bot's driver let us go to fight in our next match. Our second and final match on day 2 was against Sparrow, a brand new robot in this competition. It was a vertical drum mounted to a large wedge. On top of their 1-pound drum, the robot is really fast and its driver is incredibly talented. We measured our bot up to theirs right before the match and found that if we flipped Solar-Storm upside down, the weapon would hit almost precisely at the height of his weapon axle. As the match got started, we did have some driving problems, eventually causing us to lose the fight. That said, we got a couple good chunks of Sparrow. After disassembly, we found that the main frame plate had taken a pretty decent compound bend. That said, because of the 5052 we had from SendCutSend, we bent it back into shape just fine. That was the competition for Solar-Storm. We have some drive revisions ahead of us as well as some work on chassis manufacturing. However, all of the parts that SendCutSend made for us were made really reliably well, and they were actually cheaper than buying the stock material, so we certainly want to integrate more of that and their manufacturing into Solar-Storm as we move forward with the design. Thanks for listening.
Hey, Jacob Rogers here with our 15-pound robot, Themis. This is one of our two 15-pound robots. This robot is unique in the way that it's a vertical spinner, but it's a very tall vertical spinner. So most robots go for a lower, more compact design where you try to get under your opponents. But our whole thing is getting as much reach as possible so that we can outreach our opponent, and we almost care about driving over them more than getting underneath them. So we decided to kind of try to shift the meta a little bit with this design. I think we did pretty well. To start off the event, Themis came in against a very crazy robot called Slicey Dicey. And Slicey Dicey is a 4-wheel drive robot with 2 articulating, swinging machetes on either side. And it's a kind of a wild card to have to fight. The biggest concern with this bot was we have such a long belt, as you can see here. And we were worried about those machetes getting up into the belt and cutting the belt possibly. So that was the biggest fear coming in. So I wanted to keep my distance at first and make as calculated a shots as we could. We came in, got a couple really good initial hits. I was driving a little erratically. I'm always a little nervous at the beginning of events. My first 2 fights or so are usually my worst. Came in, got a lot of great hits at first, and then after that, I believe it was the first or second hit, we actually removed one of the machetes entirely, which was a lot of fun. Everyone was really excited to see that. The whole crowd was going crazy for that. And then just kept getting a couple good hits in there after that. And then the hits started kind of piling up. Once I was more comfortable with my driving, I was able to spin the weapon up a little bit faster and deliver those final knockout blows, and he tapped out after that fight. But really great fight. Came out of that with pretty much very little damage. You'll see that there's a couple of spots where they came in and the machete actually got lodged in, and then their weapon came around and pushed the machete further into the armor of the robot. So that had an effect on the structural rigidity of the arm a little bit. Well, we were concerned about that, but it turns out it was fine. So came out of that fight 1-0, moving on in the winner's bracket. So fight number 2, we came up against a really great robot in Stump Grinder. It was the second iteration of the robot, much lower, 4-wheel drive this time. I believe it was an all-steel frame with some titanium parts on there. Had a nasty little vertical spinner on there. I was pretty concerned about making sure that I didn't let him get to the sides of me. I spun up the weapon and then hit the button to say that I was ready, but the weapon wouldn't spin down in time because I didn't realize it was the second person to hit it. So the weapon was still spinning when it said go. So we both just decided to just sit there until the weapon stopped, and then we would just go as soon as the weapon was fully spun down. So that affected the spin up time a little bit. So he was able to come in and get, I think 1 or 2 decent hits in. And then I was able to turn towards him. I got a really great hit to where it actually shot his robot up into the glass right in front of my face, kind of stepped back a little bit. And that fight was so much fun. And as soon as he landed, he was turned a little bit away from me. And I was actually able to hit the side of him. I didn't realize that I did this, but it shot the drive axle for the back right wheel through his batteries, and the entire thing caught fire. And it started pretty slow. I didn't even realize it was happening. And I came in and gave it a second hit, and I guess that jostled things loose, and then huge plumes of fire coming out, as you can see in the video, and it was just a spectacle for everybody. So moving on, I was 2-0. Decided to mix it up a little bit. We have our newest member of Team Themis, Ainsley, and she's a freshman this year. She did a lot of great work on this robot, and in practice she was doing great with her test drives. So we decided to put her in there against Team Elk Robotics robot Vulcan. It was a flamethrower, and I thought this would be a great chance to for her to get a chance to get some fighting experience in. And I knew since it was a flamethrower wedge, it couldn't do insane amounts of damage to a robot. I mean, could still melt the insides, but I was pretty sure that with her abilities, she could keep the weapon pointed towards the other robot and kind of keep the flames at bay, and that wouldn't harm the robot too much. However, the driving of our opponent was fantastic. Kept their robot pointed towards us the whole time. Ainsley, like I, was extremely nervous in her first fight, and missed the first hit by just a little bit and hit the barrier. But then course corrected, did really great throughout the rest of the fight. Pulled off an epic KO. Got her opponent into the corner and just hit just the right part, and it actually ruptured the entire butane canister, created a giant fireball, a lot like the Saw Blaze uppercut fight. So I was really happy to see that, and I couldn't have been happier the outcome for Ainsley in her first fight. So at that point, we're 3-0, still in the winner's bracket. I believe we were moving on to the winner's bracket final. And this winner's bracket final was against a friend of ours, also former president of Florida Polytechnic University's Purple Fire Robotics, Joseph Petullo, and his brother. And they had this really great robot called Bumblebee that was based off of our robot Hyperion, a lot of similarities. So this was definitely the fight going into it that everyone was like, I don't know if Themis can win this one. And I didn't know if Themis could win this one. I knew we had the reach, but I knew that they would have the mobility, and they would be able to outmaneuver us if I wasn't careful. So I made sure that when I came to this fight, I was pretty careful and kept the robot facing towards them. Luckily, we got a lot of good hits. We got them flipped over, and the fight was over pretty quick. That one really surprised everyone, I think, and it surprised myself. We took some hits to the front bumpers here that help us from tipping over on our sides, and then a couple hits to the self-righting bit that keeps us from getting stuck on our faces. These bumpers over here help us from getting stuck over here, and it bent in one of these, and then the other one was torn off entirely. So we need to look at new methods for mounting these, probably using washers, and find a different way to mount these. But they definitely took all of the damage for the main chassis. The main chassis did not take any damage in the fight. So thank goodness we move on to an undefeated 4-0, and we're in the final. So this is the final. Hyperion and Bumblebee fought it out to get there. Unfortunately for us, Hyperion wasn't able to take the win on that one, so we had to come up and face Bumblebee once again, very fierce competitor. Obviously having to go through the ringer with a lot of really great robots. They had to take some time to make sure that the robot was fixed up. Themis, for the most part, we just had to recharge the batteries and get back in there. Second fight, actually, with Bumblebee, I was a lot more aggressive with my driving. I understood that I could outreach them, and their mobility seemed a little bit damaged because of the previous fights. So just went after it, got that first good hit in, flipped him over, and then just kept hitting him from there. And fight was over pretty quick. I believe we removed one of the front wedges, one of the welded front wedges on there, and that was it. That's the tail of the tape right there. Perfect 5-0, 5 knockouts. Most of the fights lasted 90 seconds or less, so didn't even use half the time we were allotted to get those knockouts, and it was a really great result. Everyone on my team was fantastic. I wanted to say thank you to Alexander Dubs, and say thank you to Ainsley Stafford. this was just absolutely fantastic. Everyone is working together really, really well, and everyone learned a whole lot. And then just to cap it off, for fun, decided to throw the robot in against the 3-pounder that someone wanted to send to bot heaven, and rip that thing open right after the second Bumblebee fight. And then Alexander Doves took this thing in against, I believe, 4 other robots at least in the Rumble, and KO'd them all within 2 minutes. And they were all gunning for Themis, and so officially 5 KOs on the day, unofficially, 9 KOs on the day, plus, that little 3-pounder. But it was really great. I think the things that helped us in this event were the redesign of the weapon. It's now an asymmetric design instead of a straight bar. It gave us a lot of bite. We maybe need to work on hardening the tip because a bit of it actually chipped off. The front arm that keeps us from tipping over works great. It didn't bend at all. It did exactly what it was supposed to. The bumpers kept getting bent in and out, or kind of torn open a little bit, but they did their job for the most part and protected the mainframe. We might look at how to mount those better. And for the most part, we took minimal damage. The one corner got bent up a little bit, but it was no big deal. We just hammered that back down. And it was a fantastic event. This was Purple Fire Robotics, only our second gold, and personally my only tournament win ever. So we were really stoked about this result, and we will take you on to the next spot.
Hi, I'm Russell Williams, a freshman at Florida Poly, and I drive Insomnia, our 1-pound ant-weight vertical spinner bot. The weapon for this robot turned out to be insanely good, with the 1/4-inch thick AR400 blade only being possible from SendCutSend. Now, along with such, the 1/8-inch thick aluminum wedge from SendCutSend also held up extremely well, it being able to take massive hits without losing any of its shape. However, sadly, even though the robot was underweight and was working before the competition, the weapon had an electronics failure with its motor, which resulted in it having to be taken off, simply so it wouldn't be hit at the competition. But even with such at the competition, I learned quite a lot, and I'll talk about it after the matches. Now, in this first match that I was put against Vibe Check, an insanely powerful horizontal spinner. Even with this being my first ever combat robot fight, I know I was going to have to rush them and stay on them, hoping to not let that blade get up to speed. And I furthermore hoped that if I could get their side, I could push them into the wall with their robot's blade hitting the wall, and hopefully just getting them to destroy themselves. But they got a very good grip and a very good hit on my right side panel of the wedge, with basically ripping off the wedge due to the machine screws, and with myself still trying to get used to the turning and moving of the bot while going against another moving bot for the first time. But soon after the hit, and after a little bit more of chasing, as I tried to get in a position to get around them to the side, I heard the announcer say, "Vibe Check got up to full speed."
Vibe Check is spinning up to full speed.
And with my wedge not fully on, I did not want to find out what would happen, so I contemplated and then tapped out. Even with it being hit off from that insanely powerful hit, the metal wedge actually mostly just took scratches and chip damage, with the main point of failure of it being the actual 3D printed chassis and the machine screws. Now, in my second match, I went up against a vertical spinner called Good Enough, and had a similar strategy to get to their sides and push them to the wall. However, my wedge did not seem good enough to lift them up. Ironically, while theirs made me flip over on them a few times throughout the match. This even put me flipped upside down at the end against the wall at an angle that I could see my battery through a tiny gap in my lid, making me tap out in case the other bot spinner hit it, which it likely would have. Now, their spinner actually mostly did chip damage to the underside of my wedge, both likely because of how thin their spinner was and because of the properties of aluminum. But this was overall a really fun fight. Now, all of this has been taken into consideration as I redesigned the robot's chassis to be made out of UHMW and use plastic screws instead of machine screws, and redesign the wedge to both be more effective against horizontal spinner bots by being a singular piece and have a much shallower angle, with furthermore it being made out of titanium. Thank you for your time.